In this video, I'm going to answer another basic question about derivatives, and that is, when does a derivative exist? And now this is kind of like a limit in that a derivative almost always exists, except for a few instances. So let's jump right in. Once again, a derivative is always going to exist except for three cases. And these are actually pretty straightforward cases. Unlike in limits, where limits there was quite a few steps to figure out, these are pretty straightforward. The first case, at a discontinuity, and I'll go over all these in depth. The second case is that the derivative will not exist at a sharp corner, and I'll explain what that means. And the third case is when the tangent line is vertical, because a vertical line has a slope of infinity. The first one, at a discontinuity. This really is pretty straightforward. The function must be continuous at x for the derivative to exist there, right? That makes sense. You can't have a tangent line touching a function at a point where the function doesn't exist or isn't continuous. So the function must be continuous at x for the derivative to exist there. Case 2 of where a derivative does not exist is at a sharp corner. And you really only see these in absolute value functions. Let me show you what that looks like. So we're going to look at the absolute value of x. And just look at it, and you'll see what I mean by sharp corner, right? See, if you look at x equals 0, there's a sharp corner there, right? You can't draw a tangent line. So the derivative does not exist there. But it's important to note, like limits, a derivative can exist for some x's and not exist for others. So the derivative exists for all the other points on this graph. It is just at this sharp corner right here where the derivative does not exist. The final case where a derivative does not exist is when the tangent line is vertical. Because remember, a vertical line has a slope of infinity. Really good example of this, f of x equals the square root of x. So let's look at that. So we can see in red, the square root of x, right, that's that curve, and we can see the tangent line at x equals 0 is that blue vertical line, right? It just barely touches the square root of x at x equals 0, right? So if you look at that blue line, and if I were to ask you to calculate the slope of that, like, right, rise over run, like you couldn't do that because it's infinity. So at that point, the derivative does not exist. At x equals 0, the derivative does not exist. But anywhere else on this curve, you can draw a tangent line that is not vertical. So it's only at that one point that the derivative does not exist. And that's it. That's all there is to it. Really, it's not nearly as complicated as whether or not a limit exists is. The derivative existing is really straightforward. There are just those three things there, right? So is the function continuous where you're finding the derivative? Is there a sharp corner, which really only happens on absolute value functions, right? And are you trying to find the slope of a vertical tangent line, which honestly is pretty rare. And that's really all you have to keep in mind. It's pretty straightforward, so don't make it any more complicated than it is. If you like this video or if you learned something, please like, subscribe, share with your friends, and I will keep the math content coming.